So whatever you need is, you have three factors here. One is G, F and C. So that is what you require to find the center and radius of the circle. We have an important note here. The x coordinate of the center of the circle is the coefficient of x by 2 and y coordinate of the center of the circle is coefficient of y divided by 2. We know that center of the circle is exactly the midpoint of the line segment diameter. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So welcome to the third session of the chapter Circle. In today's session, we will be discussing on the general equation of the circle. So what do you mean by the general equation of the circle? Let us see now. Show that the second degree equation x square plus y square plus 2gx plus 2fy plus c is equal to 0 is always represents a circle. Now we have to show that the equation x square plus y square plus 2gx plus 2fy plus c is equal to 0 represent a circle. So for this, let us see the standard equation of the circle. What is the standard equation of the circle whenever the center is given? H comma k, that is x minus h whole square, y minus k whole square is equal to r square. Now we have to show that x square plus y square plus 2gx plus 2fy plus c is equal to 0 represents the equation of the circle. Now let us convert this equation in this form, then we can show that it is the equation of the circle. So what I'll do here, let me shift c to the right hand side. Then I'll get x square plus y square plus 2gx plus 2fy is equal to minus c. Now add g square and f square on both sides of the equation. So it becomes x square plus y square plus 2gx plus 2fy plus g square plus f square. Here also plus g square plus f square minus c. Now I'll separate this x square plus 2gx plus g square plus y square plus 2fy plus f square. That is equal to g square plus f square minus c. So now this is x plus g whole square. This is y plus f whole square. And this is g square plus f square minus c. Now write this in this form. So this become x minus of minus g whole square plus y minus of minus f whole square is equal to g square plus f square minus c. Now you can compare the equation with center h comma k to this equation. This is in the same form of x minus h whole square, y minus k whole square is equal to r square. So here what implies h comma k is nothing but your minus g comma minus f, and whereas r square is equal to g square plus f square minus c. So this implies r is equal to square root of g square plus f square minus c. So therefore, the given equation can be symbolized in the form of x minus h whole square plus y minus k whole square is equal to r square. That's why the equation of this form is called the standard equation of the circle. That is, to represent any type of equation of a circle, we can take x square, y square, 2gx, 2fy plus c is equal to 0 as the standard equation of the circle or standard form of the circle, where the center of this circle is nothing but minus g comma minus f, and radius r is given by g square plus f square minus c. Next, we have an important note here. The x coordinate of the center of the circle is the coefficient of x by 2 and y coordinate of the center of the circle is coefficient of y divided by 2. How to find that? We know that the standard form of the equation is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So I already said the center is always given by minus g comma minus f. We can also find this. So what is the coefficient of the x here? It is 2g. So therefore here we have minus 2g by 2, which is minus g. Next, y coordinate of the center of the circle is 2f. So it is minus 2f by 2, which is minus f. So similarly, as we have calculated in the standard form, we can also calculate whenever the value of g and f are given. That is, we can find the coordinate of x and y using this formula. That is coefficient of x by 2, coefficient of y by 2 with negatives. Next, let us see the problems. Find the center and radius of the circle x square plus y square minus 4x minus 6y plus 1 is equal to 0. So compare this to the standard form of the circle. That is x square y square 2gx 2fy plus c is equal to 0. So whatever you need is, you have three factors here. One is g, f and c. So that is what you require to find the center and radius of the circle. So from this we have 2g is equal to minus 4. So this implies g is equal to minus 2. Next we have 2f is equal to minus 6. So this implies f is equal to minus 3. Next we have c is equal to 1. So what is the center whenever the standard equation is given? It is minus g minus f, and r is square root of g square f square minus c. So therefore center is minus g comma minus f. That is equal to, so we have g is equal to minus 2, minus of minus 2 is plus 2. Next f is minus 3, it is 3. Next radius r is square root of g square plus f square minus c. So g square is 4, f square is 9, c is minus 1. So it is square root of 12, or you can write it as 2 root 3. So therefore the radius of the circle is 2 root 3. Next, find the center and radius of the circle 4x square plus 4y square minus 15x minus 8y plus 11 is equal to 0. The standard equation always starts with the x square. So whenever you have any coefficient multiplied with x or y, just divide the equation through the coefficient. So here divide the equation by 4. So this becomes x square y square minus 15 by 4x minus 2y plus 11 by 4 is equal to 0. Now compare to the standard equation. Here x square plus y square plus 2gx. So 2g is equal to minus 15 by 4 here. So this implies g is equal to minus 15 by 8. Next we have 2f. 2f is equal to minus 2. So therefore f is equal to minus 1. Next the value of c is 11 by 4. So let us write the center. Center is minus g comma minus f, which becomes 15 by 8 comma 1. Next radius is square root of g square plus f square minus c. So it is square root g square is minus 15 by 8. So it is minus 15 by 8 whole square. F square is 1. Again it is minus 11 by 4 whole square. So let us solve this. This is 225 divided by 16. So this is equal to square root of 225 divided by 64 plus 1 plus 121 divided by 16. So we can take the LCM for 16 and 64, which is square root of 64, 225 plus 64 plus 484. So this can be written as square root of 773 divided by 64 can be taken as 8. So root of 773 by 8. Next question. If the radius of the circle x square plus y square minus 2x plus 3y plus k is equal to 0 is 5 by 2, find k. So here the value of c is missing. So let us find the value of c in the form of k. So we know that radius of the circle is given by square root of g square plus f square minus c. So let us find what is g, f, c. Now here g is 2g is equal to minus 2. So therefore the value of g is equal to minus 1. Next we have 2f is equal to 3. So therefore f is equal to 3 by 2 and c is k here. So therefore r is given as 5 by 2. 5 by 2 is equal to g square is 1. F square is 9 divided by 4 minus c. Square root. Squaring on both sides, we'll get this as 25 divided by 4. This is 1 plus 9 by 4 minus c. Shift c to the left side. So it is c is equal to 1 plus 9 by 4 minus 25 by 4. So c is equal to 1 minus 16 by 4. So 4 1s are 4 4s are. C is equal to 1 minus 4 which is equal to minus 3. The value of C is here k. So therefore k is equal to minus 3. Next question. If one end of the diameter of the circle x square plus y square minus 2x minus 4y plus 4 is equal to 0 is 1, 1, find the other end. So here if this is the circle given, we have a diameter whose end point is 1, 1. So let me take the other end point as point P. Next, from this equation, we can find the center of the circle C. We know that center of the circle is exactly the midpoint of the line segment diameter. So therefore, by knowing the center and this end point, we can find the point P. How? Using midpoint formula. So first let us find the center of the circle. Now we have from the circle here 2g is equal to minus 2. This implies g is equal to minus 1. Next, 2f is equal to minus 4. This implies f is equal to minus 2. So therefore, center minus g comma minus f is equal to 1 comma 2. Next, from or using midpoint formula, let me take the coordinate of P as x comma y. So whatever the coordinate I don't know, let me consider it in the form of x comma y. The midpoint formula is C is given, that is midpoint is given, that is 1 comma 2, that is equal to, so x plus 1 by 2, y plus 1 by 2. X plus 1 by 2 comma y plus 1 by 2. So compare the equation. X plus 1 by 2 is equal to 1. Y plus 1 by 2 is equal to 2. So x plus 1 is equal to 2. X is equal to 1. Next here, y plus 1 is equal to 4. Y is equal to 3. So therefore, the other end point of the diameter is 1 comma 3. Next question, if a comma b and minus 5 comma 1 are the ends of the diameter of the circle x square plus y square plus 4x minus 4y minus 2 is equal to 0, find a and b as we did in the previous problem. So let us find the center of this circle. We have 2g is equal to 4. This implies g is equal to 2. 2f is equal to minus 4. This implies f is equal to minus 2. So therefore, the center minus g comma minus f is equal to minus 2 comma 2. Now one end point is given and the other end point is taken as a comma b. So in previous case, we have taken the equation in the form of x and y. Here they have given in the form of a comma b. So therefore, using midpoint formula again, so we can write minus 2 comma 2 is equal to a minus 5 by 2 comma b plus 1 by 2. So a minus 5 by 2 is equal to minus 2, b plus 1 by 2 is equal to 2. A minus 5 is equal to minus 4, a is equal to minus 5, it becomes plus y 1. So the value of A is equal to 1, B plus 1 is equal to 4, B is equal to 3. So therefore, the end point of diameter is 1, 3. We'll meet you in the next session with few more problems on general equation of circle. Until then, keep watching, keep learning and keep exploring. Thank you.